Welcome back to the channel, guys. Let's do the next question. Move all the negative elements to one side of the array. The problem states given an unsorted array of ARR of size n, having both negative and positive integers, the task is to place all negative elements at the end array without changing the order of positive element and negative element. Okay. Without changing the order of positive and negative elements. So it says, like in the given example, it is given 1 minus 1, 3, 2, 1 minus 1, 3, 2, minus 7, minus 5, 11, 6, minus 7, minus 5, 11, 6. So in the output, it was positive on one end and negative on one end, but the positive and negative should not lose the relative order. So it is saying that it should be 1, 3, 2, 11, 6, comma. Now the negative ones, minus 1, minus 7, minus 5. All right. So how would we approach this problem? Let's look at the specifications given. It is given that we can use a time complexity of O of n and an auxiliary space of O of n. That makes the problem really simple, by the way. So we have been provided time complexity O of n and space complexity O of n. Very simple problem now. What we can do is approach one. Since we have been allowed a space complexity of O of n, we can make two arrays, size n. We have given an initial size of the array, that is n. We can make two arrays of size n, or we also use vector to dynamically allot, so there is no waste stage. Okay, this one is for negative elements, and this one is for positive elements. Now we will traverse the original array. Whenever we find a positive element, we insert it into the positive elements array, and whenever we find a negative element, we insert it into the negative element array. So for the example, like first we encounter 1, so we will move to the positive element array, put 1 here. Then we encounter minus 1, minus 1, 3, 2, then minus 7, minus 5, then 11 here, and then 6 here. Now we have got two arrays for one for positive elements and one for negative elements. The process from here is really simple. In the original array, first put all the positive elements, then put all the negative elements. You've got your answer. I hope I should not extend this approach anymore. Now move to the approach 2. If you see, we are using O of 2n here. We can reduce that by using only one array for negative elements. Like make an array or vector per se to save useless space complexity. Store all the negative elements like we got 9, minus 1, minus 7, minus 5. But while traversing, use this pointer like in the question we were given, like we got the count like here in this question. The count of positive numbers is 1, 3, 2, 11, 6. That is 5 elements. Sorry, I don't have to do anything with count. Let me just state that our original array, let me state the original array once again. Just a minute. Yeah, this was an original array. So I keep a start pointer in the array. Like this was my original array. 1, minus 1, 3, 2, minus 7, minus 5, 11, and 6. I keep a start pointer here, like initializing it with start equals to 0. Whenever I encounter a positive element, I put that element on the start. Like I will encounter 1. Here I will mention the updated array. Okay. So 1, I encountered 1, I put it into the start. Okay. Start plus plus. Start comes here. I got minus 1, I put it into the negative array. Okay. Start remains here only. I got 3, I put 3 here. Start comes here. I got 2, put 2 here. Start comes here. I got minus 7 now. Minus 7 goes here in the negative array. I got minus 5 now. Minus 5 goes in here in the negative array. I got 11 now. So I put that on the start position. 11. Start comes here. I got 6. I put 6 here. And start comes here. Now, for putting the negative elements in the specified order, I can use up till start is less than n. Put all the elements of the vector of the negative vector into the main answer. I hope that was clear. Let's move to the code. I'm directly approaching the approach number 2 because approach 1 was fairly simple. Like here, we declare a negative vector. For simplicity, I'm just naming it V because I don't want to name it again and again. Okay. Now, for and a start pointer, int start equals to 0. For int I equals to 0, I less than n, I plus plus, starting the first traversal. If arri is less than 0, if we encounter a negative element, v dot push back arri, put the negative element into the negative array storing the negative elements. Else means that positive, we have encountered a positive number. Just take care that 0 is a positive number. It will not be treated as a negative number. Okay. So else contains all the numbers greater than and equal to 0. If we encounter that, we have to put that position on the start position. Okay. So arri arr start equals to arri, right? And after that, start plus plus. After this for loop, we will have a good array of positives. Like the first half is completed. Now we have to only put the negative elements at the end by proposing them. Okay. Now for int I equals to 0, I less than v dot size I plus plus arr of start equals to v of I, and then start plus plus. Because start was already pointing on the position where the element was to be inserted, we have got our array, and now we can return, because if you pay attention that it is given to be void, so we don't have to return anything. Thus I'm using the return statement to declare that the function has ended. Let's hope it works. Trying the compile and run statement. It is working from the compile and run. Fingers crossed for submit also. It is submitted successfully. Hope you liked the video. Please don't forget to like and subscribe. Thank you for watching. Meet you in the next video.